So, division is going to get a lot easier after you watch this video. Now, I know what you're going to ask me right before you even do it, is how come you didn't show us a short method earlier? Well, because this method does not always work, and I'll explain in a little bit. So, practice. If we were to take x minus 2 and figure out how many times or multiply that by what to get 2x cubed minus 3x squared plus x minus 4. If you watched the last video on how to divide using long division, you'd be able to do that real quickly. So, what I would like you to do is pause the video and do it, just to prove to yourself that you know how to do long division. So go try. If you did it correctly, you should have ended up with 2x squared plus x plus 3 plus a remainder of 2 over x minus 2. Now that was using long division from the last video. When you have the opportunity, you're going to really want to use synthetic division. It's so much faster, slightly different, much easier if you ask me. The only thing is you can only do it when you are dividing by something that will give you a nice easy 0 to work with. So what you would do is you would have to ask yourself, x minus 2 equals 0, what does x equal? And in this case, x equals 2. So what you're going to do, instead of putting x minus 2 in front, you're going to put just the 0 or 2 in front. And then inside this big L, which we're just going to use the leading coefficient. So we have a 2, a negative 3, a 1, and a negative 4. So notice we just used the coefficients and the constant for the last one. And what we're going to do here is we're going to do something a little bit different. So pay attention closely. To use synthetic division, what you're going to do is you first drop down the first term, always, which is 2. But now what you're going to do is you're going to take this first number, 2, and multiply it to this number. So 2 times 2 is 4. And what you do is you put it right here. And the difference between long division and synthetic division is now you actually add. So negative 3 plus 4 is a 1. And you're going to do that exact same process again. So now you're just going to take this number and multiply it by the 2. 2 times 1 is 2, so that goes right here. Add these together. 1 plus 2 is 3. One last step. You take the 3 and you multiply it to the 2, which is 6. Negative 4 plus 6 is 2. And I know what you're thinking. How does that represent this at all? Well, what you do is you just now put in your variables, starting one below this. So this is an x cubed, is what we started with. So this is 2x squared plus 1x plus 3 plus our remainder over what we divided by, which in this case is x minus 2. And it is the exact same answer as you see using long division. That only took that long because I explained every little step. Wait till you start doing those on your own. It's going to be great how much faster it works. Okay? Now, that again is called synthetic division. If you would like to see it again, obviously, just go back about a minute or so and watch it again. But it is much faster. The only thing is it can only be done when you have something like an x minus 2 or an x plus 3 where you can very easily get the 0. So, how are we going to use synthetic division? Well, we're actually going to factor. We're going to factor really big terms like this coming up next, and they're going to get a lot bigger as well. So factoring can be done using synthetic division. Synthetic division is a form of factoring. And one of these days I'm going to show you how you can actually factor even problems like Batman with synthetic division. So what's going to happen here is we're going to start factoring using synthetic division and other forms as well, but I'm going to give you a 0. So I'm going to tell you that this has negative 3 as a 0. Now I know that because, well, I made up the problem, and our graphing calculator will tell you that. If you were to take your graphing calculator and type 2x cubed plus 11x squared plus 18x plus 9 into the graphing calculator, you would find that a -3 is one of your zeros if you were to look at it at the table or in the graph. Now first you're going to look at this and you're going to see that there are 4 terms and you're like, well, I'll just group it. But remember, when you're using grouping, the inside of those parentheses must be the exact same, and in this case they would not end up being the exact same. So what you're going to do is you're just going to take this, make sure that there's no placeholders that are needed. It does go in descending order from x cubed all the way down to a constant. So again, I gave you the 0, so -3 is the 0. We're going to put in our leading coefficients, which are 2, 11, 18, and 9. We are going to bring down the first number always, and then just start asking yourself, what's -3 times 2? That would be a -6. 11 minus 6 is 5. What's a -3 times 5? That would be a -15. 18 minus 15 is 3. What's a -3 times 3? That is a -9, and boom. You have no remainder, and that's what you need. You cannot factor using synthetic division if you get a remainder. So, if I tell you to factor something and you get a remainder, it's most likely that you made a mistake. When we get to more challenging problems where I just straight up tell you to factor, if you get a remainder, that just means you could have started with the wrong 0. But if I give you one of the zeros, like I did in this problem, it should work out easy. Okay? So, we're not done. The only thing you've done is you've just used synthetic division with a -3. So, remember, this is an x squared plus 5x plus 3. Since the directions say factor and they don't just say divide, you need to factor completely. So, this can continue to be factored. We could use Batman. 2x squared times 3 is a 6x squared. And if we were to ask ourselves what multiplies to 6 but adds to 5, we're going to say that that's 2x and 3x. Bring down our last term, bring down our first term, and you're going to group these Batman style. Factor out a 2x, leaving you with an x plus 1. Factor out a 3, leaving you with an x plus 1. And you are almost done. Your factored answer is your GCFs, the insides of the parenthesis written once, and you're not done. You also have to say, hey, where did this -3 come from? He came from an x plus 3. Okay, that's the new one. So when you're using synthetic division or when you're factoring, remember, if you were to FOIL this back, you would have to get the original problem. And simply multiplying 2x and x is only going to get you to 2x squared. We have to also remember to use him in your final factored answer. Okay? And now you're done. That is completely factored. There's nothing else you can do, so you are finished with that problem. Okay? So, we have another example. Again, I am giving you one of the zeros. You are going to find the other zeros. So this is asking you to solve for all the other zeros or solve for x. I'm going to give you 2. You find the rest. That basically means go use synthetic division again. Okay? So what I would like you to do is pause the video and try it. We'll set it up. We'll put the big L. 1, -2, -9, 18. The 2 I gave you goes in front. I would like you to use synthetic division. And after you're done using synthetic division, see if it can go further and factor as far as you possibly can. Go do it. So first of all, if you use synthetic division correctly, you would end up with 1, 0, -9, and no remainder. So that would give you an x squared, 0x minus 9. So you have x squared minus 9. And then, of course, if you were to factor it completely, you would have your x minus 2 from this given 0. And then you have an x plus 3 and an x minus 3 because this is the difference of 2 cubes. So then your three solutions are 2, -3, and 3. However, the directions just said to list the other zeros. So you just had to find your two other zeros that come from using synthetic division on this problem, which are -3 and 3. Okay? So again, synthetic division is a form of factoring. So we're going to use a calculator to find a zero, and then we're going to find all the zeros. So basically, I can tell you to just find and factor an entire problem because you have that thing known as a graphing calculator. So what you're going to need to do really quick on your own is get your graphing calculator and type this example into Y1. And what you're going to do is you're going to see a graph that's going to look a little bit like this. It's going to start low, it's going to swoop through, and it's going to come bounce down, and it's going to go back up. And those two crucial points would have been all the way back at a -6. And it's going to be over here at a +3. Now those are the two answers that we would find using our graphing calculator. So when your graphing calculator gives you two different zeros, which one do you pick? And the answer is any one you want. It doesn't matter. So if we're going to factor this and solve, what we're going to do is we're going to pick one. I'm going to pick 3. And I'm going to put the 3 on the outside, and then inside we're going to have our 1, -1, -21, and 45. Again, there's 4 terms, but it couldn't be grouped. Drop down your 1, and that's going to give you a 3. So we have a 2. That's going to give us a 6, which is going to give us a -15. And 3 times a -15 is a -45. So see, you have no remainder. If you would have accidentally used, say, -3, for some reason, you would not get the correct answer. You'd have a remainder, and that would be bad. So, again, we put our x squared, our x, and we have our -15. So we have x squared plus 2x minus 15 here. And don't forget, we also have our x minus 3 because the 3 came from an x minus 3. But we're not done. We can continue factoring. So this can go further. Don't forget your x minus 3. What multiplies to a -15 but adds to 2? That would be an x plus 5 and an x minus 3. So as you can see, we're just about done factoring. The only thing you might want to do is write this as x plus 5 times x minus 3 squared, because look, we have 2 of them, the exact same thing. And if you remember correctly from one of the graphing videos, that's because we have a bounce over here. Remember, that's known as a double root. So there we go. So x is equal to -5 and 3. 3 is a double root. We do not have to list 3 and 3. You can just leave 3 once. Okay? So that is that. So we have one last example here. And I'm just going to give it to you right now. I'm going to give you this big, long x to the 4th plus 7x cubed minus 7x squared minus 63x minus 18. And I'm going to say, go have fun. This is going to require you to use synthetic division probably twice. And we are going to talk about this problem in class tomorrow. But try it on your own if you'd like and see if you can handle it. If you can handle it, you are in great shape. Okay, this is Longo and I am out. See you, bye.